Hi, everyone. Today we are here to talk about Restate Cloud with a side of some new Restate 1.5 features. I will try and make this as approachable to the widest possible audience. If you have any questions, a few of my colleagues are in the chat. Please ask questions. We will stop and answer them as we can. If time permits, we have some interesting demos for you. Hopefully the demo gods will be smiling upon us today. So my name is Pavel. I am an engineer working across Restate and Restate Cloud for the last couple of years. And I will tell you about the latest Restate Cloud launch that went out just last week. So you are probably well familiar with Restate. If you're on this call, Restate is used by customers across many industries to reliably process financial transactions, build AI agents, run stateful workflow orchestration, and many other use cases. Hope to give you some ideas of what Restate can do for you and your systems in this talk. Restate is high throughput and low latency. Even in Restate Cloud, we can see very, very high numbers in terms of the transaction processing possible. The other fantastic thing is that we work with many different programming languages, thanks to the variety of SDKs that we offer. So while Restate itself is a single converged zero dependency binary that is very easy to run and operate yourself, we aim to make Restate Cloud an extremely easy platform for you to start with Restate and deploy and operate Restate services. So since the start of early preview in the middle of 2024, customers have launched thousands of Restate environments on Restate Cloud, and we have just recently made Restate Cloud commercially available. We now have several paid tiers. I'll show you in a little bit. You can see those on the website, of course. We are available in 2 different regions, and your data will be only locally stored and processed, depending on which one you choose at launch. One new feature that is now available on Restate Cloud is shared accounts among teams. So we'll talk a little bit about how to best use that a little bit later. A variety of new features that I'll show you demos of, and we'll also touch on a handful of new Restate 1.5 features that make operating systems much easier than before. So a few words about what's new in Restate 1.5. Restate Cloud, of course, runs the latest release always, and we've upgraded all existing environments to this current release. 1.5 adds some significantly improved invocation, observability, and long requested features, such as being able to resume and restart as new previously crashed invocations. So this lets you, as an operator, suspend and move around to a fixed version of your code invocations that would otherwise end up either bouncing around and maybe costing you money, or flooding downstream services with requests, or might require you to implement a dead letter queue and resubmit those invocations yourself in some other way if they failed. So what exactly does Restate Cloud, a Restate Cloud environment look like? For all intents and purposes, Restate Cloud environment is just a logical Restate server cluster running on Restate managed infrastructure. So Restate Cloud organizes environments into accounts that you can easily share with teams. These can be different sets of people, depending on how you choose to use the feature. You can use accounts or teams to either separate, to support separate business entities, or perhaps you require a very hard separation between your development and production environments. So you can use accounts or teams to separate these. And every account can contain multiple environments. Each environment is logically its own separate Restate server. And within that Restate server, which is individually addressable over its public DNS name, you can have standalone isolated API keys, different services deployed, and they contain the local data isolated to themselves. Importantly, we should note, it is not possible to host your own custom business logic on Restate Cloud. So for that, we have a variety of integrations and examples with other providers where you can host your Restate SDK-based services. These include popular choices like AWS Lambda and Cloudflare. And today I will walk you through deploying a Restate service on Vercel serverless functions. Some other examples include Kubernetes, Amazon ECS, and a little bit later on in this presentation, I will walk you through some new and exciting features for those of you operating private Kubernetes clusters and managing Kubernetes deployments. With that, let's move to our first demo. So I mentioned the first demonstration is going to be for the new quick start deployment targeting Vercel, and we are going to use of course, Restate Cloud. This is the landing page. When you first open Restate Cloud, you will see a page that looks that asks you to create an environment. In my case, I have already accepted terms and conditions, created a team, and created an environment called Restate Demo. I'm just using the free tier in this environment, but you can choose something else. So one of the great new features that we have in Restate Cloud now allows you to try out deploying a service without even running any code, without managing any deployments. So if you just click on the Try Quick Start, we have a built-in Restate managed onboarding service that you can deploy to your Restate environment. And if you just follow the prompts, it will give you a lovely guided tour of some of the new features that are available and introduce you to how Restate works. So I'm not going to spoil that. I'll leave it to you to try that out for yourself. This is only available in Restate Cloud, so I invite you to try it out. Instead, what I would like to do is this environment has currently no services deployed in it. So what you would do typically is go to the Developers tab, and now we offer you a variety of templates. Today, we'll use the Vercel template, but there are plenty others that all work great. And I've already prepared the API keys for this deployment so that we don't have to mess with that. The other prerequisite that we are going to need to use for the Vercel deployment demonstration is this administrative URL. So I have already gone and configured a repository with some action secrets. So I have cloned the Restate Vercel template, and I've pre-configured the admin URL and auth token. The admin URL is not actually secret. Anybody can guess it based on your environment ID, but this is just a convenient way to templatize, to pass variables into the shared workflow. So I'm going to switch to the code editor for this next step and show you that deployment. If there are any questions so long, please feel free to put them in the chat. We can stop and talk about any detail of the presentation if that's interesting to you. So here we can see the Vercel template, which I have customized on in a very minor way, which we'll see shortly. The interesting part is that it contains a GitHub workflow, which is going to take care of the Restate deployment for us. So in order for me to trigger a deployment, you saw that in my cloud environment, there was no current services deployed yet. So I'm going to make an empty commit just to trigger this deployment, but should probably be in the correct directory for that. And I will just push that to main. And while that is happening, I am going to switch back to the web browser and show you the GitHub action executing, and we can talk about some more about what is happening. So the API key that I had already pre-installed inside of my GitHub repository is going to allow the GitHub workflow, which we can see is currently running, to contact Restate Cloud and deploy my Vercel environment, which is open just here, and register that service running in Vercel with Restate Cloud. So let's see where we are. I think that deployment is completed. We should be able to see, if we are back to overview, a very convenient time to get me signed out of my Restate Cloud session. And we can see we have revision 1 of the Vercel greeter deployed. Fantastic. How did that work? Well, inside of the GitHub action that we deployed, we are using the Restate CLI together with the URL and together with the API key that I plugged in earlier that had been sourced from Restate Cloud, and this registers the deployment here. If anybody wants to interrupt me, please jump in. So now we are back to Restate Cloud. Apologies about that. So I am showing you my Restate Cloud environment. So we have the Vercel greeter. We have a new revision deployed. I don't know if I got missed in the screen sharing. The restate action executed, which completed that deployment. Okay, so what can we do with this? Well, conveniently, Restate's web UI has a playground with which we can interact with the deployed services. And so we can see here that we have a greet operation that I'd love to call. I'm going to edit the body. I'm going to send the API request, and I'm going to, spoiler alert, that there is a bug in this. So this request will not complete, or should not complete if all went well. We have an invocation here, which happened just 16 seconds ago, and its status is paused. So let's explore what happened. We received a request to the Vercel greeter's greet operation. We started running, and we have encountered an error. So what might that be? It's an intentional exception that I inserted into this operation. One thing that I want to highlight here, though, is that this invocation is now in paused status. So this restate environment in Restate Cloud, by default, we have a retry policy that sets invocations to not retry indefinitely, but rather enter a paused state when the maximum attempt has been reached. And for this specific deployment, I will show you in a moment, I've customized the retry policy to give up much more quickly than the default, just so that we can see the effect of this sooner. So back to the code. Let's have a look at what this greeter is doing. It is registering a service with a single greeter method, and very obviously there is an intentional error in here. The retry policies are now customizable at a more granular level than before. Previously, we used to only support this at the either server or service level. Now we can do a lot more. You can read more about that in the documentation. And for the service, I have set a very aggressive policy that will give up and pause the invocation after just about a second. I also want to draw your attention to something else that we saw. How does Vercel know to allow Restate Cloud to call it? So I'm just going to go back to the Restate, to my Vercel deployment and show you something else that is notable. So if we look back in the Vercel runtime logs for this environment, we'll see there had been a recent invocation. This is 1918 in my local time. And we see this message that was logged by the Restate SDK running inside of Vercel that says, warning, we are accepting requests without validating the request signature. This means that potentially somebody else could deploy this in their Restate server and make calls to my service. That's not ideal. So what Restate Cloud allows you to do is every environment contains a unique public key with which outgoing requests leaving Restate Cloud and reaching your Restate services are signed. And under security, we can see what this public key is. This is specific to my particular environment. So if I grab this key and I go back to the code, I'll show you how we can enable that and authenticate that the request origin is in fact my specific Restate Cloud. So I've already got this here. It should match. Yes, it does. So let's commit the push, commit the fix, and the change to the public key. And I'm going to push that back to GitHub. While that is happening, what we should see, what we should expect to see is when the deployment runs, we'll now see a second deployment appear in Restate Cloud. It might just take a moment for that deployment to complete. You can see this fix deployment is still running. That action has not completed yet. So while that is going on, remember we still have our paused invocation. This earlier one is not relevant to us right now. And what we'd love to be able to do is here we now have the new revision 2 of the Vercel deployment. What we would love to be able to do is go back to our invocation, which has been paused, and you can do this through the Restate CLI, or you can do it in bulk through the API. And I want to resume this invocation. And on resumption, I want you to execute not on revision 1, which is typically historically where Restate invocations have always been pinned to the specific deployment revision on which they started, but rather to the latest revision 2, which contains our bug fix. And I forgot to press the live updates timeline button. So actually, it managed to complete before I even did that, but the rest of the work, the service execution completed, and we got the end result. So now that's finished. Any questions so far? Please feel free to stop, put questions in the chat, raise your hand if you'd like to talk. Let's go back to the slides. Okay. So there's one more audience that I'd like to talk to. Historically, Restate has been very focused on working very well with serverless, and AWS Lambda has been a big focus for us. And I hope that you can see with these new quick starts that we have a variety of other targets to choose from. But another core audience for Restate is larger enterprises who may be running large Kubernetes deployments, and particularly those who operate Restate services and large private networks. So not everyone can easily expose services out to the internet, and we really wanted to make sure that Restate Cloud works great, even for those enterprise customers who might not be able to easily accept direct inbound HTTP from the web. So integrated into Restate Cloud is a dedicated tunnel service. And we also make available a tunnel client that you can easily deploy in highly available fashion, either directly yourself. It's available as a Docker container, and it just uses a Restate Cloud API key, just like making any other admin operation. Or even more excitingly, more recently, the Restate operator has gained the ability to create and manage Restate deployments. So it can take a template for a pod, create a Restate deployment out of that, manage Rainbow deployments and multiple revision registrations, just like we saw with the serverless platform supporting multiple concurrent deployments and copies of the code being deployed. And not only that, but the Restate operator can optionally establish a tunnel back to Restate Cloud and perform the registration operations of these Kubernetes deployments itself. Not only that, the Restate tunnel can act as a gateway for other applications that run inside of your Kubernetes network, and you can use Kubernetes network policies to control that. So that callers within your private network can also make ingress invocations to your services that are mediated by Restate environments running in Restate Cloud. How does that work? Imagine on your private network, you have some Restate service deployed. By deploying the tunnel client, it is able to make an outbound TLS connection on standard port 443 to the Restate Cloud tunnel service. And by registering itself there, it makes available a special callback endpoint at which you can register Restate services to be invoked by the Restate Cloud environment. And so whenever Restate needs to perform service discovery or service invocation, it reaches back to the tunnel service, provided the tunnel client is connected. It will be able to deliver traffic back into the tunnel client, which will reach out to the Restate service that you are managing yourself. This could be a long-running service running as a container somewhere on your network. It could be running within Kubernetes. And optionally, like I mentioned before, other internal clients that run within your network will also be able to use this tunnel client to communicate with Restate, with your Restate Cloud environment, just as if you're reaching out over the internet like an external client might with an API key. The benefit of using the tunnel client for ingress or administrative operations is that the tunnel client can inject the necessary API token in the request path. So you can use normal Kubernetes network policies that may be more intuitive to you, or any other access control mechanism that you use on your local network. And in the reverse direction, we saw earlier how the public key that ensures that Restate requests originate from the appropriate environment are also is also configured in the tunnel client, and it strictly validates that traffic coming back from the Restate Cloud and reaching into your private network always has that property validated. There's a whole lot of information. Let's see if we can make that more concrete with another demo. So for this next demo, I should probably set the context a little bit. What I have running my computer is a local Kubernetes environment. But before we get there, I just wanted to show you what the Restate tunnel, the kind of bare bones DIY Restate tunnel experience looks like. So you noticed how we can create API keys in the Restate Cloud Environments Developer tab. So I've already done that, and I have put that key into the file env.sh. And the start command is really simple. So it just references this Restate auth token or API key that we just created, the specific environment, and the public key that is unique to my environment. We can give tunnels a name. Names are important insofar as I can run multiple tunnels. So if I had multiple Kubernetes clusters that all needed to talk to and register services in the same Restate Cloud environment, I could give them distinct names. For the most part, you don't need to worry too much about it. So if I run this if I start this environment, it actually creates, we have multi-AZ endpoints in the tunnel service. So it starts multiple concurrent connections to the Restate tunnel service to achieve high availability. And this tunnel behaves as though, the tunnel client behaves as though it's a local Restate service. So it would, local Restate server. So it would still expose all the same port 9070 for admin operations and port 8080 for ingress and so on. And so if I fetch the deployments, for example, we can see that we have the two revisions of my Vercel greeter that we deployed earlier. Similarly, I can reach, if the API key that I'm using is suitably authorized, I can also make ingress requests here. Okay, so far so simple. The tunnel deployment, the Restate tunnel client gives you the ability to deploy services that run in isolated networks. One request that we've heard over and over is, how can we make it easier for folks running Kubernetes to manage Restate deployments? So the Restate operator is historically has been focused on using on managing Restate clusters, and recently has gained two new Kubernetes custom resource types that it can also support. These include Restate Cloud Environment and a Restate deployment. So let's first look at what a Restate Cloud Environment might look like. A cloud environment is there so that we can model deployment targets which run remotely in Restate Cloud as targets for Restate deployments. We'll see that in a moment. So for now, all I've done is I have a local Kubernetes that's running on my machine, and I have deployed the latest Restate operator 180, and that supports the Restate Cloud Environment CRD. So let's deploy that. Let's deploy an environment called Restate Demo. I have already pre-created a token which contains the API key for my environment. And I've already specified the signing public key, just like for the tunnel. So let's see if I can get my magic Kubernetes incantations right. First of all, let's just see that the Kubernetes operator is running. It is running. There is a single pod. It's a very small local Kubernetes deployment. And I'm going to apply this Restate Cloud environment in the Restate operator namespace. Okay, so now if we have a look at what resources are running in this Restate operator namespace, we'll see that actually it started a pod called tunnel restate demo. And this is deploying a restate tunnel very similar to the one that we saw deployed earlier, but it's now managing it in a more abstracted way. And we have this notion of a restate demo cloud environment within my Kubernetes cluster that I can target, excuse me. So next, we can have a look at what the deployment itself actually looks like. And this is how we might model a restate deployment. So you can see that it doesn't look that dissimilar to a normal Kubernetes replica set or deployment. The resource is called restate deployment, and we provide essentially what it looks like, a replica set template specification. I'll talk in a moment a little bit more about the revision history limit, but suffice it to say that we can specify a container. I have this container called Kubernetes greeter, and once again, spoiler alert, this top revision is actually broken. So typically we want to deploy Kubernetes services, restate services in Kubernetes in their own dedicated namespaces. So just to show you, there is no namespace, nothing in this namespace yet. And I am going to create this Kubernetes greeter in this namespace. And if we watch this for a second, I can also show you the live logs from the restate operator as it's reconciling what is running here. But we can see that it has created a service and a replica set, and that replica set has one copy, has one pod managed by it, and this pod, to nobody's great surprise, is running that container as specified. Now, here's the magic bit. Because the restate operator already has established a tunnel back to Restate Cloud, if we go back and list the deployments that are running in Restate Cloud, we should see the service. And here I want to show you something else that is cool, which is the Restate CLI supports, once again, if you are suitably authenticated, which it has forgotten about my session from earlier this morning. If I suitably authenticated, Restate Cloud can use multiple environments. So it can use typically the localhost 9070 port, but if you log in with your cloud credentials, you can set it to use a specific cloud environment. And so we can now list the services, and we can see that in addition to my Vercel greeter, which is on revision 2, we now have a new Kubernetes greeter at revision 1. And to not bore you with the details, I am going to, without showing you, just go back and make an execution against it, which we will see is failing momentarily. So I'll just use the playground once again. And I'll send an API request to that. And once again, this Kubernetes container that I deployed initially has got a bug, and the invocation has become paused. So we can see that the target was Kubernetes greeter, the greet method specifically, and has now become paused. And the reason is very simple. There is a very similar bug that is just throwing an error right at the start of the handler. So what we can now do with the Kubernetes deployment is that, see some raised hands. if anybody wanted to it's definitely not intentional that chat is disabled. Thank you for flagging that. It should not be disabled. On my screen, it says let contributors send messages enabled. I'm going to toggle it off and on again.
I think we've been having some issues with the chat indeed, but you can use the Q&A tools if you want to ask questions.
Great. Yeah, okay. So it is intentional that I'm still showing you the IDE console. So all I wanted to show you is that deploying a new revision is as simple as bumping the image revision. Okay, so all that I'm going to do is apply the latest manifest for the Kubernetes greeter deployment. And before I do that, I just once again want to show you, here are the resources running, the Kubernetes resources running in the Kubernetes service namespace. So we have one service, one pod. So let's go back and deploy the Kubernetes greeter deployment now with the fixed revised image. And we just watch that momentarily. Almost instantly, it created a second service and a second replica set with its own deployment that is now running the new container revision. I forgot which is which, but if we go back and look at the service listing and specifically the deployment listing, oh, I see. The demigods are not entirely with us. So what happened is this image here is using a different service name, and it did not register as a new revision on the same version. So that is entirely my fault. But what I'll show you now is we'll come back here and we'll rebuild the container. So the bug was, once again, an exception being thrown. The service name that I wanted specifically to match is Kubernetes greeter. So let's fix that quickly. Fortunately, this is TypeScript, so the build will be exceptionally fast. And if we grab this new revision, we can paste that in here and apply it once again. So now we should end up with three replica sets, 3 services. And if we list the deployments, we should see 2 distinct revisions for the Kubernetes greeter. And here we can see exactly that. This might be slightly harder to see compared to the UI in Restate Cloud, but I want to show you that you can use both. Maybe to make things a little bit more obvious, I can remove this redundant one. Okay, so now what has happened is we still have our paused invocation, and for this, I could go back to the UI and resume it once again, moving it to the latest invocation, just like we saw before with the Vercel function. I think I would like to leave more room for questions and discussion. So maybe I will skip that and open the chat, open the mic to the room and see what questions and comments we might have. So one of the interesting features of the Kubernetes deployment and the restate operator and the restate deployment specifically is that we can specify, I just want to resume this and I will move it to the latest revision 2. And we will once again see it run to completion nearly immediately. And we got the result. One thing that I wanted to show you, maybe if we have time, is if we keep deploying new revisions of this Kubernetes service, the Restate operator is smart enough to monitor the deployments, the different deployments, revisions of these services, and track how many outstanding invocations there are that are pinned to the older revisions. So historically, with AWS Lambda, every single version function gets its own distinct deployment revision. And on Lambda, it doesn't cost you anything. You can just keep running, keep that code deployed, and invoke it whenever you feel like it. With Kubernetes and long-running platforms, things get a little bit more complex. So instead, what we do is the Restate operator will periodically issue an introspection query against that specific deployment ID. And once it has been drained, it will scale down the replica set to 0. So the number of historic replica sets of your deployments that will be retained is configurable via the what do we call it? The revision history limit. And replicas will be scaled down to 0, even within that history limit, once running restate invocations have been drained and they reach 0. The replica sets are just kept around in case you might need to, for whatever reason, perform a rollback and delete the most recent deployment, thereby rolling back to the previous revision. Okay, with that, here are the new tiers that we have just added. In addition to all these, there is also an enterprise tier where we can customize virtually anything and everything. We also offer some additional enterprise-y features there, such as we can do more tailored service terms and higher availability and throughput requirements. One thing that is worth mentioning is that we are committed to keep the free tier as a useful resource for explorations and hobby projects. So that's not going away anywhere. Please give it a try. I would also like to mention a few words about security and compliance. So we've recently made available a client-side journal encryption reference implementation that is based on AWS KMS, specifically for the TypeScript SDK. This allows customers that have extremely sensitive workloads, such as those in highly regulated industries like healthcare in the United States and elsewhere, to continue to use Restate Cloud in a way that still gives you full visibility and doesn't compromise the developer experience nor the operator experience. You can still see and look at your invocations, for example. On the other hand, that allows you to send payloads and data through Restate that even Restate Cloud cannot read. So the keys remain in your possession, the data is fully in your control. We are also currently undergoing an audit with an external auditor company, and we'll have more news to share on our security and compliance posture in the coming weeks. The other exciting bit of news is that custom SSO integration is also now on our roadmap. So with that, thank you very much.